Hello 8th class students. This is your chapter number 6, Combustion and Flame. We use different kinds of fuel for various purposes at home, in industry and for running automobiles. Can you name a few fuels used in your homes? Name a few fuels used in trade and industry. Now this is the chapter based on two concepts. One is combustion and other is flame. We are using various type of fuels in our homes, for example LPG, kerosene. Now name a few fuels used in trade and industries. We use coal there, petrol, diesel there. What fuels are used for running automobiles? Diesel, CNG, petrol. Your list will contain fuels like cow dung, wood, coal, charcoal, petrol, diesel, and compressed natural gas, that is CNG. Now you are familiar with the burning of a candle. What is the difference between the burning of a candle and the burning of a fuel like coal? So difference is what? When we burn the candle, it burns with a flame, and when we burn a fuel like coal, it burns without a flame. Maybe you were able to guess right. Candle burns with a flame and whereas coal does not. Similarly, you will find many other materials burning without a flame. Let us study the chemical process of burning and the types of flame produced during this process. Now, before learning various concepts or facts, let us know what is combustion. What is combustion? Combustion simply involves the definition which is given over here, a chemical process in which a substance reacts with oxygen to give off heat is called combustion. Underline this, a chemical process. It is a chemical process. What is a chemical process? Which give us new product, which is irreversible. So, a chemical process in which a substance, any substance, reacts with oxygen, means in the presence of oxygen gas, it gives us heat. This process is known as combustion. Very simple definition. You can write down the question. Define combustion. Now this is your question. This question may be in the form of what is combustion, what do you mean by combustion. So a chemical process in which a substance reacts with oxygen to give off heat is known as combustion. Now, what are combustible substances or fuel? This is the next question, very important. The substance that undergoes combustion is said to be combustible. Any substance which undergoes combustion is said to be combustible. It is also known as fuel. The fuel may be solid, liquid or gas. Sometimes light is also given off during combustion, either as a flame or as a glow. What does it mean? We get light in the process of combustion. This light may be in the form of a flame or as a glow. As a glow means without flame. Without flame. Right? Now comes here again. We can perform a similar activity with a piece of charcoal. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? What is your observation? When you perform this activity with a piece of charcoal, you hold this piece of charcoal near a flame of a candle. What do you observe? Right, we find that charcoal burns in air. We know that coal too burns in air, producing carbon dioxide, heat and light. But this charcoal, it burns without flame. It burns without flame. In the reactions mentioned above, magnesium and charcoal are combustible substances. Now here, magnesium burns to form magnesium oxide, and it also produces heat and light, but it burns with a flame. Magnesium burns with a flame, but charcoal burns without flame. This is the difference between the reactions between magnesium and charcoal. Both are combustible substances. Both are combustible substances, and the difference lies in the combustion, in the way of combustion, in the method of combustion. While burning magnesium, it burns with a dazzling white colored flame, and when we burn charcoal, it burns without a flame. Now, Bujo asked this question here. We were told that food is a fuel for our body. We were told that food is a fuel for our body. It is very much right. Food is a fuel for our body, and the burning of food is known as respiration. Burning of food is also known as respiration. This process is known as respiration, and we are getting energy by this process in the form of ATP molecules. Carbon dioxide is produced. Carbon dioxide is produced in this process. So, food is definitely act as a fuel for our body, which gives us energy in the form of ATP molecules. Rightly so, in our body, food is broken down by the reaction with oxygen and heat is produced, and this process is known as burning of food, that is respiration. Now activity 6.1, collect some materials like straw, mastic, kerosene oil, paper, iron nails, stone pieces, glass, etc. Under the supervision of your teacher, try to burn each of these materials one by one. If combustion takes place, if burning takes place, mark the material combustible, otherwise mark it non-combustible. So these are the substances given in your table. Material: wood, paper, iron nails, kerosene, stone piece, straw, charcoal, mastics and glass. Now two columns are there, one is combustible and one is non-combustible. What are combustible substances? The substances that undergoes combustion, they are known as combustible, and the substances which does not undergoes under combustion, they are said to be non-combustible substances. Now, in which category the material wood falls? It is combustible. Paper is also combustible. Iron nails are non-combustible. Kerosene oil, combustible. Stone piece, non-combustible. Straw, again it is combustible. Charcoal, combustible. Matchsticks, combustible. Glass comes under the category of non-combustible materials. Clear? Can you name some more substances which are combustible? Of course, you can name many substances. You can add those in table 6.1. Let us investigate conditions under which combustion takes place. What are the conditions under which combustion takes place? Before doing this activity, before doing this question, let us do activity 6.2. Caution is here, be careful while handling burning candle. Now fix a lighted candle on a table. First of all, take one table and fix a lighted candle on it. Then put a glass chimney over the candle and rest it on a few wooden blocks. See here, these are two wooden blocks and you have lighted a candle here. Cover it with a glass chimney. Chimney means the above area of this tumbler is empty. Now rest it on a few wooden blocks such a way that air can enter the chimney. Then observe what happens to the flame. Now remove the blocks and let the chimney rest on the table. Just you can see in the diagram, you have removed these two wooden blocks. Now finally put a glass plate over the chimney. In C diagram, you have removed the wooden blocks as well as you cover the open chimney with a piece of wood. Then watch the flame again. Piece of glass plate. You can use glass plate also. Watch the flame again. What happens in the three cases? This is your observation. Does the flame flicker off? Does it flicker and give smoke? Does it burn unaffected? Can you infer anything at all about the role played by air in the process of burning? Now this activity shows that what is the role of air in burning. Okay, this activity is for, write down here, to show air is needed for burning. Air is needed for burning. How will you prove this? By doing this activity. In first case, simply air enters from this side and from above also. So the candle will burn unaffectedly. In the next case, there is no air at the bottom, so it flickers. Then in the third case, the candle is not able to burn. Why? Because there is no supply of air from bottom as well as from the top of the chimney, because it is covered with a glass plate. So it shows that air is very much essential or needed for burning. This activity shows the role of air. Now, after performing this experiment to show that air is essential for burning, we find that for combustion air is necessary. Now here is the question, that what are the conditions under which combustion takes place. So combustion takes place, burning takes place under these three conditions. Number one, underline, when air can enter the chimney from below. It means in case B, when air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available. So these are the different conditions. Now in which condition the combustion takes place? Properly, that is when air can enter the chimney from below as well as from above. The first case is the best one, A1. Now Bujo asked one more question here. We have read that the sun produces its own heat. Sun produces its own heat and light. Is it also some kind of combustion? Of course, yes. Look here, in the sun, heat and light are produced by nuclear reactions. Nuclear reactions, they take place in the nucleus or in the core of the sun. And what is the process over here? In the nucleus, the reaction takes place, burning of hydrogen takes place. Okay, hydrogen is the main fuel inside the sun. It burns and it is converted into helium gas. In this way, it produces a large amount of own heat and light. Clear? So these reactions, nuclear reactions, they produce heat and light in the sun. And what happened in these nuclear reactions? Simply in the nucleus of the sun, the hydrogen gas is converted into helium gas. This is the nuclear reaction inside the sun. Now activity 6.3. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does the charcoal stop burning after some time? Can you think of the reason why it stops burning? Yes, when there is no supply of air, it stops burning, but a charcoal burns without a flame. Okay, it glows and gives us heat and light. Now next is, you might have heard that when clothes of a person catch fire, the person is covered with blanket to extinguish fire. Can you guess why? Just to cut the supply of air. Just to cut the supply of air, a person is wrapped into a blanket, because for burning oxygen is essential. As you know, you have done the activity. When we wrap this burning person with a piece of blanket, simply it cuts the supply of oxygen. There is no oxygen for fuel, so it stops burning. Now recall some of your experiences. Does a matchstick burn by itself? How does it burn? You have seen matchstick at your home. Does a matchstick burn by itself? No, of course not. It needs some rubbing process. You must have had an experience of burning a piece of paper. Yes, many times you have this experience in your life. Does it burn when a burning matchstick is brought near it? Yes. Can you burn a piece of wood by bringing a lighted matchstick near it? Many times yes, or many times no. Why do you have to use paper or kerosene oil to start fire in wood or coal? What is the reason that we are using some paper or kerosene oil to start fire in a big forest or a wood? Wood means forest here, or coal. Okay, simply furniture wood, it also needed some kind of initiative like burning paper or kerosene oil. So have you heard of forest fires? Many times you heard in news that forest fire caused a lot of destruction. During extreme heat of summer, at some places dry grass catch fire. From the grass it spreads to trees, and very soon the whole forest is on fire. It is very difficult to control such fires. Okay, so this is a scene of forest fire. Now, do these experiences tell you that different substances catch fire at different temperature? Of course, yes. The lowest temperature at which a substance catches fire is called its ignition temperature. Now here question becomes like this. Define or what is ignition temperature? So what is ignition temperature? The lowest temperature at which a substance, this substance may be your petrol, fuel, wood, charcoal, coal, okay. So the lowest temperature needed for the combustion of this substance, okay, at which the substance catches fire is called its ignition temperature. And for various fuels it is different. Can you tell now why a matchstick does not catch fire on its own at room temperature? Why? Because to its ignition temperature, lowest temperature must be higher than room temperature. Why does the matchstick start burning on rubbing? Because it gets its ignition temperature and it catches fire after rubbing. The history of the matchstick is very old. So this is in this box, in this yellow colored box, the history of matchstick is given. Okay, let's start the story. The history of matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches. So, what is the structure of matchstick? Pine wood dipped in sulfur. They were used as matches in ancient Egypt. Now, in modern safety, match was developed only about 200 years ago. What is the age of modern match? 200 years, near about. A mixture of antimony trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. This is very important. In exams, you may asked this question that what is the chemical present in the head of the matchstick. That is, it is a mixture of antimony trisulfide, potassium chlorate and white phosphorus. Some glue is also added to it. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of the match. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. So these days the head of safety match contains only, what is the formation of matchsticks these days? Underline this. The head of the safety match contains only antimony trisulfide and potassium chlorate. This is very important. It can important as well as you may get this in the form of fill-ups or true and false. Okay, the rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous. When the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. Now come here. After listening this story, we find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. Have you ever seen cooking oil catching fire when a fry pan is kept for a long on a burning stove? Many times you have seen this. Kerosene oil and wood do not catch fire on their own at room temperature. But if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood? Of course, yes. Because the substance having low ignition temperature will burn first. Does it mean that we need to take special care in storing kerosene oil? Yes. The following activity shows that it is essential for a substance to reach ignition temperature to burn. Next is activity 6.4. Now caution here is be careful while handling burning candle. Make 2 paper cups. Okay. By folding a sheet of paper, pour 50 ml of water in one of the cup. Heat both the cups separately. With a candle, what do you observe? We observe that the cup containing water will burn later than the cup having no water. Okay, why? Because its ignition temperature is lower than this ignition temperature of dry paper is lower than the paper filled with water. Okay, so the ignition temperature of a substance is low, it catches fire earlier. What happens to the empty paper cup? It will burn. What happens to the paper cup with water? It burns later on because adding water makes the ignition temperature it needs more temperature. Okay. Does water in this cup become hot? Yes, sure. it becomes hot. If we continue heating the cup, we can even boil water in the paper cup. Can you think of an explanation for this phenomena? The heat supplied to the paper cup is transferred to water by conduction. Conduction is a method through which heat is transferred. So, in the presence of water, the ignition temperature of the paper is not reached, hence, it does not burn. Very simple. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. This is very important. What are inflammable substances? Those substances which have very low ignition temperature and can easily catch fire with a flame. Examples of inflammable substances are, what are the examples? Underline again. Petrol, alcohol, liquefied petroleum gas, LPG. This is the full form of LPG. These substances are inflammable. Why these are inflammable? Because they have very low ignition temperature and they can catch fire easily. So remember one thing, if the ignition temperature is very low, it means the substance is inflammable. And what are the examples of inflammable substances? Petrol, alcohol, liquefied petroleum gas. Next is 6.2. How do we control fire? How do we control fire? You must have seen or heard of fire breaking out in homes, shops and factories. If you have seen such an accident, write a short description in your notebook. Also share the experience with your classmates. Find out the telephone number of the fire service. No, this is 102. It is important that all of us know the telephone numbers of the fire service. The 102 is the telephone number of fire service. And what about ambulance? It is 108. Now next is, this is the scene of firemen extinguishing the fire by throwing water under pressure. Now does your city town have a fire brigade station? Yes. Suppose your city is Chandigarh, its fire station is in sector 17. When a fire brigade arrives, what does it do? It tries to, fully give its efforts to extinguish the fire. It pours water on the fire. What does it do? Water cools the combustible material so that its temperature is brought below its ignition temperature. This prevents the fire from spreading. If the temperature comes below its ignition temperature, it stops burning. Water vapors also surround the combustible materials, helping in cutting off the supply of air, so the fire is extinguished. Now you have learned that there are 3 essential requirements for producing fire. What are the 3 important essential requirements for producing fire? Underline again. These are, first of all, we need a fuel. Second one is air is needed for burning, and third one is heat is needed to raise the temperature of the fuel beyond ignition temperature. Now fire can control by removing one or more of these requirements. The job of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel, or both. So what is the function of an fire extinguisher? Very simple answer. Number 1, it helps to cut off the supply of air. Number 2, it helps in bringing down the temperature of the fuel down to its ignition temperature, or both these. Notice that the fuel in most cases cannot be eliminated. If, for instance, a building catches fire, the whole building is the fuel. Types of combustions. What are the different types of combustion? If a substance is catching fire very rapidly, okay, we find that the gas burns rapidly and produces heat and light. Such combustion is known as rapid combustion. Okay, so what is rapid combustion? A combustion which takes place rapidly. There are substances like phosphorus which burn in air at room temperature. They are very reactive. This type of combustion in which the material suddenly bursts into flames without the application of any apparent cause. They need no cause to burn. Such type of combustion which takes itself is known as spontaneous combustion. We generally have fireworks on festival days, for example, Diwali festival. When a cracker is ignited, a sudden reaction takes place. And due to this reaction, a lot of heat, light, sound is produced. A large amount of gas is formed in the reaction and it is liberated. Such type of reaction is known as explosion. So from here, when a cracker is ignited, sudden reaction takes place, evolution of heat, light and sound takes place, a large amount of gas is formed and liberated. This is known as explosion. Define explosion. Explosion can also take place if pressure is applied on the cracker. Next is flame. Now our combustion portion is over now. Now next is flame. Observe an LPG flame. All of you have LPG at your homes. Can you tell the color of the flame? Yes, it burns with a blue flame. What is the color of the candle flame? It burns with reddish orange color. Recall your experience of burning a magnesium ribbon, dazzling white light. If you do not have experience of burning the remaining items in table 6.2, you can do that now. Now, record your observations and mention whether on burning the material forms a flame or not. You can see in this diagram, this candle is burning with this color flame, LP is burning with blue flame. You can mark the difference. Now, fill this table. This is material given to you. Whether it forms flame or does not form flame. Candle, it burns with flame. Magnesium burns with white dazzling flame. Camphor does not form flame. Kerosene stove, it burns with flame. Charcoal again does not form flame. Now 6.5, structure of a flame. Activity 6.5, light a candle. Caution is be careful. Hold 4-5 centimeter long thin glass tube. This is the thin glass tube. With a pair of tongs, introducing its one end to the dark zone of non-flickering candle. Flame, bring a lighted matchstick near the other end of the glass tube. Do you see flame caught at this end of the glass tube after a while? Yes, because its temperature come near to its ignition temperature. If so, what is that process? What is it that produces a flame? Notice that the wax near the heated wick melts quickly. So the vapors formed over here, they cause the burning flame. Okay. So what do you observe from this activity? The substances which vaporize during burning gives flames. Very important. Underline this. Those substances which vaporize during burning, they give flames. For example, kerosene oil, molten wax rise through the wick and are vaporized during burning and form flames. Whereas charcoal on the other hand does not vaporize. It does not vaporize and so does not produce a flame. In activity 6.5, could the vapors of wax coming out of the glass tube be cause of the flame produced? Yes. Okay. This is the cause. The vapors of wax coming out of the glass tube, be the cause of flame produced at the other end. Okay. The vapors produced due to heat at the other end of the glass tube, they causes here burning flame. Okay. Next is, when the candle flame is steady, introduce a clean glass plate, slide into the luminous zone of the flame, outermost zone of the flame, put a glass slide. What will you observe after 10 seconds? You observe one circular blackish ring. Okay, so look here. A circular blackish ring is formed on the glass plate slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Then hold a thin long copper wire. Hold a thin long copper wire just inside the non-luminous zone of flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. Does it indicate that the non-luminous zone of the flame has high temperature? In fact, this part of the flame is the hottest part. Okay, the outermost part, the color of the outermost part is blue. It is the hottest part of the flame. Now this diagram is very important, showing different zones of candle flame. So prepare this for your exams. Hottest part is the blue one, inner part is moderately hot, and the innermost part is least hot. Okay, middle zone of partial combustion, yellow color. Complete combustion takes place in the outer zone and it is blue in color. Innermost zone, unburnt wax, vapors, black. Okay. Goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Why do they use the outermost zone of the flame? Because it is the hottest part. Because it is the hottest part of the flame. That is why the goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Now next is, what is a fuel? Recall that the sources of heat energy for domestic and industrial purposes, they are mainly wood, charcoal, petrol, kerosene. These substances are called fuels. Now what are the features of a good fuel? Good fuel is one. Number one, it should be readily available. Number two, it is cheap. Number three, it burns easily in air at moderate rate. Number four, it produces a large amount of heat. Number five, it does not leave behind any undesirable substances. These are the 5 features of a good fuel or an ideal fuel. However, this is very rare that a fuel is an ideal fuel. Something is missing, whether the fuel is having different costs at different places. Some fuels are cheaper than others. Make a list of fuels familiar to you, group them as solid, liquid and gases. Next is your topic, fuel efficiency. Suppose you were asked to boil a given quantity of water using cow dung, coal and LPG as fuel. Which fuel would you prefer? Give your reason. You may take the help of your parents also. Do these 3 fuels produce the same amount of heat? No. So the amount of heat energy produced on complete combustion of 1 kg of fuel is called its calorific value. Define calorific value of a fuel. It is the amount of heat energy produced on complete combustion, complete burning of 1 kg of fuel. That amount of heat energy is known as calorific value, and it is different for different fuels. What are the units of calorific value? The units of calorific values are kilojoule per kg, that is symbolic form kilojoule per kg. These are the units of calorific value. Okay. Calorific values of some fuels are given in this table. Amount of heat energy produced on complete combustion of 1 kg of fuel. If the fuel is cow dung cake, its calorific value is, after burning 1 kg of cow dung cake, it gives us the heat energy of near about 6000 to 8000 kilojoule per kg. You can read all the calorific values in this table. The highest calorific value is of hydrogen, that is 1,50,000 kilojoules per kg. Now, burning of fuels leads to harmful products. What are these harmful effects? The increasing fuel consumption has harmful effects on the environment. Number one, the carbon fuels like wood, coal, petroleum release unburnt carbon, and this unburnt carbon particles, these fine particles are dangerous pollutants causing respiratory diseases like asthma. Number two, incomplete combustion of these fuels gives carbon monoxide, which is very poisonous gas. And if it is dangerous to burn coal in a closed room, the carbon monoxide gas produced can kill person sleeping in that room. Very dangerous. Oh, so that is why we are advised never to sleep in a room with burning or smoldering coal fire in it. Number three, if the combustion of the most fuels releases carbon dioxide, then it is one of the major ingredient of the global warming. Increased concentration of carbon dioxide in the air is believed to cause global warming. Now, what is global warming? Here question arises, what is global warming? Global warming is the rise in temperature of the atmosphere of the earth. Very important. The increase in temperature of Earth's surface is known as global warming. This results, what are the effects of global warming? Melting of polar glaciers, which leads to rise in sea levels causing floods in coastal areas. Low-lying coastal areas may be permanently submerged under water. Now, fourth main effect of increasing fuel consumption is burning of coal and diesel releases sulfur dioxide gas, SO2. It is an extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen oxides. Oxides of sulfur and nitrogen dissolve in rainwater and forms acids like sulfuric acid, nitrous acid, carbonic acid of carbon dioxide with water. And such type of rain containing all these acids is known as acid rain. So what is acid rain? Acid rain is a mixture of oxides of sulfur and nitrogen gases dissolved in rainwater, which forms sulfuric acid. Okay. It is very harmful for crops, buildings and soil. You have already learned about it in class 7th. The use of diesel and petrol as fuels in automobiles is being replaced by CNG, compressed natural gas. What is the advantage of this? CNG produces the harmful products in very small amounts. CNG is a cleaner fuel. This is your chapter number 6, Combustion and Flame. I hope you all enjoyed a lot. Thank you. Have a nice day.